Okay, so I'm going to go through this a little quickly here, but this is what we reviewed yesterday. So I'm going to try to find a good spot to put that microphone. There we go. Hopefully that works. Hopefully you can hear me. All right, so let me go to, we used a quiz. That's not what I wanted. All right, here we go. We used a quiz to review, and then you guys are going to get that post-quiz today. You saw it. You took the pre-quiz early last week, so we just went over a few things. So here's the review. Number one, the atomic mass for sodium. Well, I'm going to go back to this. So if you look at sodium here, the atomic mass is down here at the bottom. It's like 22. It's a little hard to read, 22.9897. So really 23, we can round up. It's okay to round up on that. So my answer would be 20. Okay, it's not wanting to write. That is strange. 23. There we go, 23. So then atomic number for aluminum. If I'm looking at aluminum, it is right here. And the atomic number is that number at the top. And for us, for aluminum, it is 13. So this is going to be 13. So then let's look and see what these numbers tell us. So number of protons in potassium, number of electrons in potassium, and number of neutrons in potassium. So that is 3, 4, and 5. So let's look at potassium right here. I know that is a little hard to see, but potassium's weight is 39.0, so we're talking it's like 39, and its atomic number is 19. So if I draw this out up here, and it's okay to round that to 39. My protons are always coming from that number. My atomic number and my protons will always be the same, okay? It tells me how many protons there are. Now, all of these we're assuming are neutrally charged, or they have no charge, so they're neutral. So if I have 19 positive protons, then I also have 19 negative electrons. So I'm gonna write 19, 19. Now, as far as neutrons go, this mass, my mass comes from adding my protons and my neutrons together. So what I get is I know my mass is 39, I know my protons are 19. So what you end up doing is you just take 39 minus 19, you just subtract the two numbers. So in this case, potassium has 20 neutrons. All right, so now let's look at charges. We have the electrical charge of phosphorus and the electrical charge of sodium. So let's look at that. We have phosphorus here and we have sodium here. Now I had you guys write charges on top of your periodic table. And when something is charged like this, like a second ago, I just told you, like if it's neutral, if it's a neutral atom, it will have the same number of protons and electrons. Well, in this case, if it is charged, it is called an ion. And in this case, sodium ion would have a +1 charge. The phosphorus ion would have a -3 charge. So this is -3, this is a +1. Then we're going to look at valence electrons. We want to know how many strontium has and how many neon have. I also had you write at the top of your periodic table just numbers like this. That is how many electrons are in the outermost energy level, also known as valence electrons. Strontium right here has 2 valence electrons. And what was the other one? I can't remember now. Strontium and neon. Okay, and neon has 8 valence electrons. It is complete, it's full, it's stable, it's happy. Everything down that 8th column is. So strontium is going to be 2. Neon will be 8. Number 10, are boron and aluminum in the same family or the same period? Now remember, sometimes family, you'll also hear it called group. So I'm looking for boron and aluminum. So here's boron, here's aluminum. They are up and down, that is the same family. Now remember, they have a +3 charge, they have 3 valence electrons. They are very similar. That's how I remember that families are up and down, because even if you think you are completely different from your family, genetically you guys are similar, right? So these guys are similar, they are in families, if it's going up and down. So this is going to be family. All right, then my metals and non-metals, selenium and cadmium. We're looking at, is it a metal or a non-metal? sure which side is metal and non-metal, I always look here at oxygen. It's a gas. I know oxygen's a non-metal. So this is my non-metal side, which means selenium is a non-metal, which means this is my metal side. So cadmium is a metal. Okay, so selenium is going to be non-metal. This one is metal. Number 13, if I have one atom of aluminum, how many atoms of fluorine would bond with it? Well, here's where you've got to look at charges. If you look at your periodic table, aluminum, I'm going to erase all this. Aluminum has a +3 charge, and fluorine has a -1 charge. All right, so I would need 3 fluorines. So that's how I can tell how many I'm going to need. You always look at those charges. Those charges want to equal 0. Number 14, if I have an atom with a +3 charge where electrons lost or gained. Well, remember, electrons are negative. So if I have a positive charge, I lost negative electrons. Number 15, I put this on here because kids, they know how to find neutrons, just like we did up here. But then we get to this and they're like, that can't be right. And they always tell me that hydrogen has 1 neutron, when it doesn't. Remember, neutrons are taken by subtracting these two numbers. Well, this is 1 and this is 1.00 whatever. So 1 minus 1 is 0. So hydrogen has 0 neutrons. All right, let's look at the short answer. What 2 of the 3 subatomic particles can change in number? A lot of times, as soon as students see subatomic particles, they're like, I have no idea what you're talking about. But then yesterday, I was like, guys, 3 things. What 3 things do we talk about? So they were like, okay, well, proton, electron, and neutron. And then I was like, we know one of these change because we talk about it changing all the time, and that's our electrons. Now, one we haven't really talked about, we talked about in Chemistry 1 just vaguely, we will do more with it in Chemistry 2, my neutrons, they can change. That's how we get radioactive elements, carbon-14 versus carbon-12. If you look at here, carbon weighs 12, but you can also get carbon-14. That weight comes from protons and neutrons. It's because we have neutron change. Protons cannot change. The reason for this is because it would change the element. And as much as I think people would love to be able to do that, we can't. People have tried for many, many years and it's not happening. Here's what would happen. If you could change, imagine having mercury being like, I'm going to go from 80 protons and I'm going to make it down to 79. You now turn, you make mercury and you make it into gold. Or say you have something like, I'm trying to think here, aluminum. We see aluminum metal all the time. Say you start changing protons to where you get gold. We can't do that. And that number, that atomic number, is always proton number. So just not happening. All right, number 17, carbon does not have a charge. This is because it covalently bonds. What does it mean to covalently bond? It means that it is sharing electrons. Okay, remember, that has to be 2 non-metals. And remember that hydrogen, even though it's on the metal side, it is an exception. It is a non-metal. Number 18, show the formula for calcium and chlorine. Is this ionic or covalent? Well, if you look, I have calcium here. I have chlorine here. Metal and non-metal, so it is ionic. So it's ionic. Circle it. And then I'm looking at charges. Calcium is a +2, chlorine's a -1. So I'm crisscrossing these numbers, just the numbers. So it's CaCl2. All right, 19, show the formula for sulfur dioxide. Is it ionic or covalent? Well, one thing that gives it away is if I see a prefix right away, it is covalent. But you could go back here and you can see that sulfur and oxygen are 2 nonmetals, which make it a covalent bond. Covalent. Now here I have sulfur and I have 2 oxygen. That's what that dioxide is telling me. SO2. So to do my dot diagram, and this is why covalent has a little bit more going on, you have to do these dot diagrams. 6 valence electrons. Oxygen has 6 valence, but there are 2 of them. So altogether, I have 18 valence electrons from SO2. So what I do is I put the single one by itself, attach the other two. There's 2, 4, 6, 8, 10, 12, 14, 16, 18. So I asked the kids, I was like, is everything okay? They were like, no, sulfur is not happy. So they take and they share. You cannot just take and give because then oxygen wouldn't be happy, right? So you take and share. All right, number 20, looking at the periodic table, what is one trend that occurs? It says think back to that graphing we did. So I did this and I had them write this on their periodic table. So you can write this on your periodic table, this is fine. After looking at their graphing worksheets, I had them circle francium and write biggest, radius. Okay, this is my largest element, my largest atom. So it makes sense as you go down, all right? Because look, 1, proton, 3, 11, and you can see the weights increase. So this makes sense that it's the biggest. But if you look back, thank you, if you look back this way, you're like, but wait, my proton number is going down, my weights are going down. Here's what happens. When you get down here to the end, to your noble gas, which is very happy, they're stable, they have a full outer shell, they hold those electrons a little bit tighter, a little bit closer to their nucleus. So it tightens them up, it makes them slightly smaller. So francium ends up being your biggest one. So the answer to that question on the worksheet is, one of the things you could say is as you go down a family or a group, the radius gets bigger. You could tell me as you go to the left of the periodic table, the radius gets bigger. I also had them circle helium and write highest ion energy. That's ionization energy. How much energy do you need to lose an electron? All right, so this makes sense. As you go across the periodic table, you get to your noble gases who are full and happy and stable and they don't want to share or give and take or anything. So it takes a lot of energy to get them to lose an electron because they don't want to. Now, the reason why as you go up is because think about this. Each time, Emerson, you can go. As you go up, you have a ring around the nucleus of electrons, a second ring around the nucleus, a third ring around the nucleus. So it's building out and out and out. So it's just like when I'm in this classroom, the kids that are closest to me, I could control them easier than I can the ones farther away from me. All right, so that's what's happening is it's easier to pluck off those electrons or to lose one that is further away. So you could say as you go up a family, you have higher ionization energy. You could say as you go to the right of the periodic table, you have higher ionization energy. Now, as far as the extra credit, I went over it with them, but we, because of COVID last year, did not get to talking about these sublevels. You really need to know what these sublevels mean to do the extra credit. You won't have anything like that on today's post-test, so don't worry about it. I mean, the answer is, let me see here, 2P. I believe it was sulfur was the, no, oxygen, I'm sorry. Oxygen was the answer, I believe, to that. So anyways, don't worry about that. Let me know if you have any questions at all, and I hope to see you soon. Bye.